Hello everyone. So the question is the ends Q and R of two thin wires PQ and RS are soldered or joined together. Initially, each of the wire has a length of 1 meter at 10 degree centigrade. Now the end P is maintained at 10 degree centigrade while the end S is heated and maintained at 400 degree centigrade. This is the end P which is maintained at 10 degree centigrade and end S is heated and maintained at 400 degrees Celsius. Now the system is thermally insulated from the surrounding. That means there is no heat exchange between the system and the surrounding. If the thermal conductivity of wire PQ is twice of the wire RS, thermal conductivity is basically K, so K of wire PQ is twice that of the wire RS, and the coefficient of linear thermal expansion of PQ is given as alpha. The value of alpha is given as 1.2 into 10 to the power minus 5 per Kelvin. The change in length of the wire PQ is. So according to the question, there are two wires which are joined together. One wire is PQ and second wire is RS. Okay, suppose this is my wire PQ and this is my wire RS. Okay, now P end is maintained at 10 degrees centigrade and S end is maintained as 400 degrees centigrade and length of 1 meter in 10 degree centigrade. Length of wire is 1 meter in degree centigrade. Now suppose for PQ wire the conductivity is K1 and for RS wire it is K2. Now it is saying in the question that K1 is the twice of K2. Okay, and the value of alpha is also given in the question for PQ wire, and that is 1.2 into 10 to the power minus 5 per degree per Kelvin. Okay, so now we know that if the length is same per this wire is measuring length 1 meter in 10 degrees centigrade, so it is the same length in degree centigrade. That means rate of heat flow is same. Rate of heat flow is same for both the wires. Rate of flow of heat is same. Rate of flow of heat is same for both the wires. Suppose for wire RS it is delta Q1 upon T, delta T, and that is equals to delta Q2 in PQRS. This is for RS and this is for PQ. Rate of heat of flow, that means change in heat upon with time, delta Q2 upon delta T. Okay, now delta Q1 can be written as Ka delta T in form of K, that is conductivity. I can write this as K. This is for RS. So for RS this is K2. K2 and temperature difference is for RS is 400 minus T. We assume that this is the junction. This is the junction. At this point the temperature is T. Okay. So the temperature difference for RS wire is 400 minus T. K2A upon 400 minus T upon delta T, that is the length, which is equals to L, equals to delta Q2. Delta Q2 is given as K1A and the temperature difference is T minus 10 upon L. Now L cancel out and we know that K1 is equals to 2K2. So if I write K2 400 minus T, that is equal to 2K2 T minus 10. So from here K2 is also cancel out. So the value of T is coming out to be 140 degrees centigrade. This is the junction temperature. Okay, this is the junction temperature. Temperature at the junction of both wires is coming out to be 140 degree centigrade. Now if we want to measure the change in length of the wire PQ. So suppose on wire PQ I have taken a small segment, that is dx, this segment dx, which is x distance from this P end. Okay, now for this small segment the temperature gradient is given as the temperature gradient is basically change in temperature for a small length. Temperature gradient can be given as for this dx is dt upon dx. Now dt is for this segment is at this end, this temperature is coming out to be 140 degrees centigrade. So for this length the temperature difference is 140 minus 10, 140 minus 10, and dx is 1 meter, so I can write this is 1. Now from here the value of dx is coming out to be, from here the value of dx, that is I can write dt, that is equals to 130 dx, and I can also write this as delta t equals to 130 x. Okay, now we know that when we increase the temperature or when there is change in temperature, at that time linear expansion takes place, and for linear expansion the change in length is given as dl. Suppose dl is the change in length, that is given by L alpha delta t. So the change is dx, this is the original length and this is the total length, alpha dx delta t. This is the equation of linear expansion. Okay, this is the equation of linear expansion. Now I can write, if I calculate the whole value, so I am going to integrate this value dl, integration of dl from 0 to l delta l, because we have to calculate the change in length, that is equals to alpha dx delta t, and it is from 0 to 1, because dx is the whole dx is 1 meter in 10 degrees centigrade. So now the value of delta l will be coming out to be 130, the value of dt, if I put the value of dt, that it is 0 to 1, just a minute, before integrating this I am putting the value of dt. Okay, dl 0 to delta l, so it is alpha dx 130 x. Okay, so now alpha is constant, so alpha is, I can write alpha into 130 x by 2. Okay, x by 2. So now putting the values, I will have the value of alpha, the value of alpha will be 1.2 into 10 the power minus 5 into 130 into half. This is not x by 2, it is half. Okay, I'm sorry, this is half. Now value of alpha is 1.2 into 10 the power minus 5 into 130 into half. So after solving this, we will have the value of delta L, that is the change in length in PQ wire, that is coming out to be 78 into 10 the power minus 5 meter. And if I want to write this in millimeter, then I can write delta L equals to 0.78 millimeter. This is the change in length of PQ wire. So let's check the options. The first option, which is 0.78 millimeter, is the correct option. Okay, thank you.
Hello students, today our question is two rods, one of aluminium and other made of steel having initial length L1 and L2 are connected together to form a single rod L1 plus L2, and the coefficient of linear expansion for aluminium and steel are alpha A and alpha S and respectively. And if the length of the rod increase by the same amount when the temperature are raised by T degree Celsius, then the ratio of L1 plus divided by L1 plus L2 is, so we have A, B, C, D option is given here. So we have to find which option is correct. So the solution of this question is, we know that length is inversely proportional to length is coefficient of linear expansion so we have for aluminium we have the coefficient of linear friction is this and alpha A, and for steel is alpha S. So from this we can write here inversely, so we can write here length 1 divided by length 2 is equals to length 1 is for aluminum and length 2 is for steel. So we can write here this is coefficient of this and this is coefficient of A, or we can write from this length 2 is equals to coefficient of linear expansion of aluminum and this is for steel here. So we can write here 1 plus length 2 divided by length 1 is equals to 1 plus coefficient of alpha A, and alpha is coefficient of linear expansion for A and steel here, aluminum and steel. And if we take the LCM here, so we get L1 plus L2 is equals to, so we get alpha S plus alpha A is divided by alpha S, and in our question we can write this as we have to find this L1 divided by L2, L1 plus L2, so this is alpha S linear coefficient of steel and this is divided by linear coefficient of steel plus linear coefficient of alpha aluminum here. So this is our answer. Now we check which option is correct here. So our option C is correct here. Thank you.
Hello everyone, let's start the question. The question is, steel wire of length L is at 40 degrees Celsius is suspended from the ceiling and then a mass M is hung from its free ends. The wire is cooled down from 40 degrees Celsius to 30 degrees Celsius to regain its original length L. The coefficient of the linear thermal expansion of the steel is 10 to the power minus 5 per degree Celsius. Young modulus of the steel is 10 to the power 11 Newton per meter squares and radius of the wire is 1 millimeters. Assume that L is greater than diameter of the wire, then the value of the M in kg is nearly. So, what is Young modulus? Young modulus is Y equal to stress divided by strain, and we can write mg divided by area divided by strain is delta L divided by L, and we can write mgl divided by a delta L into n. And what is the delta L? Delta L is the change in length due to the temperature. We can write it like L alpha into delta T and put this value in Y, Young modulus, then Y will becomes mgl divided by a alpha into delta T, and from here mg divided by a alpha into delta T. We have to find the value of M, so M will be y a alpha delta T divided by G. Now put this value 10 to the power 11 into pi into 10 to the power minus 3 to the power whole squares into 10 to the power minus 5 into 10 divided by 10, and the value of the M will come out approximately pi, and it will come out 3, so M will be 3 kg. This is the answer. Thank you.
Hello everyone. So the question is, a cube of coefficient of linear expansion alpha is floating in a bath containing a liquid of coefficient of volume expansion gamma L. When the temperature is reached by delta T, the depth up to which the cube is submerged in the liquid remains the same. There is no change in the depth of the cube which is submerged in the liquid. Find relation between alpha, which is the coefficient of linear expansion for cube, and gamma L, which is the coefficient of volume expansion for the liquid. We have to find out the relation between alpha and gamma. So let's start the solution. In the question, they are saying that there is a cube which is submerged in a liquid. Suppose this is the container which is filled with liquid. Now a cube is submerged in this water. Suppose this is a cube which is submerged in this water. Okay, now we know that if the mass of this cube is m, that the weight is acting downwards because of gravitation. Now this liquid is also, according to the Newton's third law, this liquid is also apply a force on this block, and that force is known as buoyancy force Fb. So for first situation, when temperature is not before heating I can write before heating I can write FB, which is the buoyancy force, that is equals to the mg, and I know that mass is equals to the volume into density. Suppose FB equals to volume is V1, density is rho1 before heating, and G is G. And I can also, we know that volume is equals to the area into length, so I can also write area into x, the distance in which this is the x. Okay, the cube is submerged in liquid up to this height, so I can also write volume as FB equals to A1 x rho 1 G. Suppose this is my equation first. Now they increase the temperature, so after heating I can write the same equation after heating, because when we increase the temperature at that time linear expansion takes place as well as volume expansion takes place, and because of that the volume of the liquid and the cube will change. So now after heating expansion takes place, and because of that expansion, now suppose the buoyancy force will be FB dash, and that is equals to m dash G, because mass of the cube is changed because of that, because volume is changed, volume expansion takes place, linear expansion takes place. Now I can write this equation as FB equals to V dash rho dash G. Okay, or I can say V2 rho 2 Z. Okay, so I can also write FB equals to, suppose this is V2 and this is rho 2. Okay, so I can write V2 as A2x. Similarly, okay, rho 2, V2 is area into distance, so A2 x rho 2 G. Suppose this is my equation second. Now in the question they are saying the depth is same after increasing the temperature, or temperature is raised by delta T, the depth up to which the cube is submerged in the liquid remains the same. That means force acting in both situation is same. When depth is same, in the question they are saying depth is same, that means the force acting in both situation is same. So I can say buoyancy force in first situation is equals to the buoyancy force in second situation. So now putting the values of FV and FV dash, FV is A1 x rho 1 G equals to, and this is A2 x rho 2 G. XG and XG cancel out, so I have A1 rho 1 equals to A2 rho 2. Now from the I can write, from the expansion I can write A1 alpha 1 equals to, in the place of A2 I can write, this is the change in area, and change in area that means superficial expansion, and I can write superficial expansion as in A2 change equals to original value, that is A1 1 plus beta delta T, where beta is the coefficient of superficial expansion. So in the place of A2 I can write A1 1 plus beta delta T. Similarly in the place of rho 2 I can write rho 1 upon 1 plus gamma L delta T. Because of volume expansion I can write rho 1 upon 1 plus, because volume is inversely proportional to the density, so the volume expansion in density will be rho 1 upon 1 plus gamma L, which is the coefficient of volume expansion of liquid delta T. Now we know that beta is equals to 2 alpha. We know that beta is equals to, the coefficient of superficial expansion is equals to 2 alpha, where alpha is the coefficient of linear expansion, so I'm going to put beta as 2 alpha. Now the equation will be A1 rho 1 equals to A1 1 plus 2 alpha delta T rho 1 upon 1 plus gamma L delta T. Okay, so I can write this as A1 cancel out. I can write this as 1 plus gamma L delta T equals to 1 plus 2 alpha delta T. So from this equation, I can say that my gamma liquid is equals to the 2 alpha. My gamma L, that this is the coefficient of volume expansion of liquid, is equals to the 2 alpha. Alpha is the coefficient of linear expansion. Thank you.